Hey, welcome to part 1 of this multiplayer game dev series where we're building a battleship clone from start to finish. In this part, we're tackling the UI, and in part 2 we'll build out the server and integrate it. I'd like this to play out similar to the classic board game. That means players will start by placing their ships on the board, followed by back and forth turns shooting at each other, and eventually someone's fleet will be sunk and the game will be over. Let's get started. Okay, so the first thing we need is Unity, and you can grab that for free if you haven't already. You can go ahead and start a new project. Once we have a new project set up, we're going to open that project and start making the game as if it was a single player game. This is going to help us test out the UI efficiently without having to mock 2 players constantly and worry about the server and all that, when all we really want to do initially is just get the UI set up. So we're going to need 2 scenes for this. I'm just going to rename the sample scene to be the connecting scene. This is what players will see as soon as they start the game and are waiting to be paired to another player. Then we're going to go ahead and create another scene, and this will be the game scene, and you can probably guess what that's for. We're going to set up a few things just to get started here. We need a UI, so we're just going to make a canvas. And I like to make an empty object to act as the controller, so this will handle the overall control of the game. So we'll call this game scene controller. Okay, and we need some assets to make this look like something, so I'm going to go over to opengameart.org and use this Naval Battle Assets Pack. This is a good little free package that has some nice looking graphics. So we'll go ahead and download that and bring that in. So I'll make a new folder and we'll call this sprites. So all of our game graphics are going to go in here, and we'll just drag those in. There we go. All right, I skipped over a few things. One thing you have to do is, once you bring in this sprite sheet from the game pack, is configure how these are cut up. Now, I'm not sure what the original author of these intended, but I went ahead and just outlined each of these. So in here you make a rectangle around each one, or you can manually specify the coordinates over here, and then give each one a name. And for this, I'm only going to use 2 orientations of the boats. So we'll have the boat placed vertically or the boat placed horizontally. And so the players, when they're placing their ships, can switch between those 2. I also didn't use all of the ships, just for simplicity. We're going to use the Scout, or what I'm calling the Scout, the Cruiser, and the Carrier. So that's our sprite sheet. And you can see once you've defined those, Unity will show you this when you expand it. These are the graphic assets we'll be using. A bunch of these icons will be useful as well. So we'll have the hit icon, the miss, a green targeting, which we're not going to use, and then a red targeting. So these will be your cursors when you're targeting to take your turn. And then we need what's called a tile palette. So this will be a tile-based game. That means that everything's going to take place in a grid, even the cursor. So this tile palette will have a bunch of settings, and if we open the 2D tile palette, you can see these are the tiles we'll be using. We have the ships and icons, as mentioned before. We can basically just paint these onto our scene over here. So the way you make these is you take sprites from over here. We'll have to adjust our windows a little bit. And you can drag these into here. I've already done this for speed for each of these and given them a name. So the next thing we need is a tile map. And this is where we'll put these tiles we've been looking at earlier. This will give us something called grid, and we're just going to rename that to just map. And our first layer is going to be the ocean, or what I'm calling the ocean, and the radar. So the ocean is where the player will place their fleet, and the radar is where they will choose where they want to fire to attack the enemy, and where they'll see the result, whether they got a hit or a miss. We'll call this the background. Okay, so right now it's completely blank, and we need to make sure it's at the origin. We don't want this to be in some weird coordinate space. we're basically just going to paint on a bunch of our tiles. And I think we're just going to make this an 8x8 for now. That'll make things pretty simple. So if we go up here and we choose the paintbrush, you can see Unity will let us just paint these on. So 1, 2, 3, 4, 5, 6, 7, 8. And there's actually a faster way to do this. You can choose a rectangle. And we'll just go 8x8. All right, there's our ocean. And then our radar, we'll use the same grid. We'll just make it above that. So let's recenter this. There we go. So now we have an 8x8 grid for the ocean and an 8x8 grid for the radar. We can check our work by opening the game window and make sure everything looks okay. At this point, if it doesn't look like this, we need to make sure that the canvas is set up to scale things properly. We want to make sure we have this portrait aspect ratio, so we just put 400 by 600 here, and we want to control the scaling by either dimension. It's not super important, but in general, we want to be able to kind of resize this window and have it stay these proportions. So we'll just set that aside like that so we can see what we're doing. Okay, so we have the background layer. We're going to need a few more layers for each of the types of things we want to show. So let's just press Command D to make another copy of that. And we'll call this layer the fleet. This layer will show the players' boats. And then we need another layer called markers. This layer will show each turn where they chose to target and whether it was a hit or a miss. And lastly, we need one more layer. This will be for the cursor. We'll put that on the very top. The cursor will be used when you place your ships so that you can see where it's going to place. So your cursor will be the boat you're placing. And then when you're taking your turn, it will be the little red crosshairs in the radar screen. Let's go ahead and round out the rest of the UI by adding a few other elements. We're going to add a message box. And we also need a button to rotate the ship. And lastly, we want to put our logo in here. So let's adjust the alignment of these. This one we want to be anchored to the top. Let's choose our image. This button will be used during ship placement to flip it from horizontal to vertical. So we'll call this rotate. And lastly, our message box. And we'll just place this above the button and white. Okay, I think that's all we need for the UI. The first thing we're going to write some code for is this map view. And I'd like to get the cursor working first so that when you hover over this, you can see the right cursor. So let's go ahead and make a script. And we'll call this map view. And map view will be in charge of running the map view. Each time you make a new script, you're going to get this basic boilerplate, and we can keep most of this. So the first thing we need are the public fields that we'll be able to access from the editor. So let's add a tile map reference. And we need one of these for each of the layers we created earlier. The marker layer. We only need to define 3 of these. The background we never modify, so we just need the fleet, marker, and cursor layers. Next, we need to define a list of possible tiles that we can use dynamically. So we're going to make a tile array for that. Call that cursor tiles. So when the cursor changes, we can pull from this list. We also want to know what the current tile is, so we'll make one called tile. And we want to define the size of the map. And it's always going to be square, so we only need one variable for that. Okay, a few more things we want. These will not be accessible by anything else. We want a reference to the grid. That's our main map. And we want to know what the maximum coordinates are that you can actually move the cursor inside of. We'll call that min coordinate. And we need one called max coordinate. All right, when this thing starts up, we want to grab a reference to our grid. So we'll use getComponent for that. And essentially the entire time it's running, we want to be looking at where the cursor is on the screen and then translating that into a spot on the map, and then taking that map and changing the cursor wherever they are overlaying their mouse. So it's time for some math. Luckily, Unity gives us some tools to easily get some of these numbers. So we can get the cursor position relative to the screen and world. So we want screen to world point, and there's a function just for that. And we just want wherever the mouse is currently, so that's input mouse position. And then once we know where that is in the world, we want to translate that into the grid. So we need a vector3 int. All the coordinates in the grid are obviously integers because you can't have a partial grid cell. And we can ask the grid, where in the world is this position. Okay, next, we don't want to allow them to place outside the grid, so we're going to clamp that by our minimum and our maximum. We're going to clear everything, so cursor layer, just clear everything. And then we want to actually set the tile where the cursor is. Okay, so now, as this cursor tile changes, every update cycle we'll get where the mouse is, we'll translate that into our bounded tile grid space. We'll clear the tile layer for the cursor, and then we'll update the tile layer with that current cursor. Before we go any further, let's define all of our cursor tiles. Now we know we're going to use these tiles to represent both the ship you're placing, as well as these different kinds of markers, and the targeting cursor. So to make things easier, let's just order these in a way that makes sense to us. So if we decide now that the vertical ship is kind of the default, and then the horizontal is the alternate position, we can just stack these in this list from smallest ship to largest ship, and then we can put all of our other cursors and markers after that. It'll make it really easy to reference those from code later on. There we go. Now we have scout, cruiser, carrier, the red targeting icon, the hit, and the miss. We need one more thing before we can try this out. We need to go back to our script, and we need to define what these minimum and maximums are. There's going to be a couple of different modes that this map operates in, depending on what phase of play we're in. To keep things organized, I'm going to define a function that allows us to switch into what I'm calling placement mode. This is when you set your ship's positions. We'll end up with a couple more of these to switch to other modes as the play phases change. So I've defined this as size -1, so that if we wanted to in the future, we could make this more robust and able to change the size, but it's a good idea to just sort of forward think and make that a variable for now. So this will be from 0 to 7 in this case. And when this starts up, just for testing right now, we'll just call this straight away. Lastly, we need to associate each of these layers with their respective layers here on this map view component. So let's go ahead and put cursor in cursor, markers, and the fleet. And let's also make sure that these are all sorted correctly. So this order in layer, we want the bottom numbers to be the lowest. So that should be 0, 1, 2, and 3. Looks good. That should be all we need to test. Let's go ahead and give it a run. Look at that. So you can see how clamp keeps us fairly well in bounds. It's just tracking the one spot where the cursor is. So we'll need to do some additional checks to make sure you can't place a ship like this. But pretty good start. So as we go along here, this could quickly get away with us in terms of complexity. So I want to define a couple of enumerations. These will be a descriptive way to reference each of those cursors. We don't want to be referring to them by number. That would just be super confusing to look at. So we'll have one enumeration that's for ship type, and we'll have another that's for markers. And lastly, we want one more enumeration for the mode that we're in. I mentioned before we're going to have placement mode, attack mode. We also need a mode where it's disabled while your opponent takes their turn, and we might need a couple of others. So let's go ahead and make map mode an enumeration. I'm going to add a new private variable to keep track of what mode we're in. So we'll use our newly created map mode. We'll simply call that mode. And in each of these functions that changes the mode of this component, the first thing we're going to do is set that mode. So for here, this will be placement mode. We're going to need two more. We need disabled, and we need attack mode. Now we can start to change the behavior of this cursor as we go between modes. So first of all, if we're disabled, we don't want to do anything here. We don't want to update the cursor at all. So if it's mode equals disabled, simply return. No sense doing any of that if we are disabled. As we're placing ships, we're going to want to define what kind it is and which orientation it is. So we really only need to keep track of whether it's horizontal or not. So for setting the ship cursor, we need to calculate which one of these cursors we need. So I was pretty specific about this order earlier, and that was so that over here, these will line up with those. So since the scout is 1, and that cursor we want for vertical, it lies in position 0. So in our code, we're going to write ship type -1, that will get us to 0, and then we're going to times it by 2 so that each time we go up one ship type, we'll jump down to the next vertical orientation for the next ship. So it will go from 0 for the scout to 2 for the cruiser, and then down to 4 for the carrier. If they choose horizontal, we just need to add 1 onto that, and since they're in a nice order here in this array, adding 1 will get us to the horizontal orientation. So we simply put a check for horizontal, and if it's horizontal, we're going to add 1, and if it's vertical, we're not going to add anything. There we go. All that remains is to set the actual cursor to that index. So we're going to pull from our list of cursor tiles that particular index. It's a good habit to get into testing your work as you go. So we tested that we could activate placement mode. Now let's test if we can actually change the cursor. So without having to involve any of the rest of the UI, I'm just going to hard code for now, set ship cursor, and this will ask us what type. Let's go ahead and let's just choose the medium-sized one, the cruiser, and we'll start with vertical. There we go. I expect to see this vertical cruiser, and that's what we see. Might as well go ahead and check to make sure horizontal works as well. Perfect, I love it. Moving right along, we now need a way to actually place the ship in the fleet layer of the map. So if you recall, there's several layers. We've been working in the cursor layer, and now we're going to think about this fleet layer. We are currently missing the ability to click, so let's think about how we're going to add that. There's a number of ways you could do this. We're going to add a collider component, and that's going to allow us to detect mouse clicks. Let's change the boundaries of this. We need it to be just sort of generally overlapping. Any component with a box collider is going to respond to on mouse down. So up here I can define on mouse down. Every time the mouse is clicked down, we want to do something similar to what we did here in update to kind of get a hold of where they are in the world and where that is on the grid. So we could make this into a separate function, but for now, I'm just going to copy it. And turns out we want the clamping as well. To start out with, we're going to put the ship wherever they click, and we're not going to really bother with any kind of logic or anything like that for now. So we'll just call the set ship directly. And this will allow us to kind of rubber stamp the boats all over the map, just as a test. We'll make this more integrated with the rest of the system as we go on. Let's just keep using the cruiser as a test. And the coordinate will be the coordinate we calculated and clamped to the boundaries. And let's just go ahead and put it vertically for now. And to actually place the ship, we need a bit more logic. So first we need to get a hold of our cursor. But this time we're not going to set the cursor. We just want to keep track of that tile. And we're going to set in a different layer, so we want these to stick around and not be cleared out as the cursor changes or moves around. So we're going to set this in the fleet layer. Okay, let's see if it works. We know the cursor works, and we can move that around. And we just added the ability to click, so I expect that when I click, I should be able to stamp ships onto the map, which we can. So that's great. Next up, we need a way for the player to place their markers. So during the gameplay, when they're taking their turn, they're going to click on a cell in the radar view, as we're calling it, and that will send an attack command, and eventually that will go to the server to check to see if it's a hit or a miss. But for now, we just want to set it so that we can kind of rubber stamp that around up here in this area as well. Here in attack mode, I'm going to assign the cursor as the attack cursor. There we go. That gives us the red crosshairs. And then we need to change the boundary where they can move the cursor. So when we're looking at the map in this mode, this is 0, 0 here. So x coordinate 0, y coordinate 0. And when they're using the radar screen, we need to offset everything by the size of the map. So if our map is 8 cells high, we need to add 8 onto there. We don't want other parts of the system to have to think about this complexity. They should just set it as if it's 0, 0 and receive 0, 0 or 0-based coordinates. So let's adjust the boundary so that it's correct. It's going to be almost identical to this. However, the minimum coordinate, the bottom of where you can select, is going to be the height of the lower part. So we'll just put size there. The only other adjustment we need is we need to add that same offset here to the y coordinate so that everything is shifted up. Now let's create the assignment function that actually places the marker on the board. We want to know where it is, what kind, and one more complexity is going to be whether or not it's being placed in the radar view or the fleet view. So when your opponent takes their turn, you want to see where they fired at you, and those markers will show up on top of your ships. So in that case, radar, as we'll call it, would be false. But when the current player, so when you're taking your turn, you want the markers to show up in the upper part in the radar view. So we can make one function that handles both of those since they're very similar. So if we're in radar mode, we want to adjust the coordinates a little bit, again because of the offset. And we can just do some vector math here. We're going to add the size of the map to the y component. And now on the marker layer, which we haven't seen yet, we're going to set a tile. Before we can test, we need to adjust our clicking functionality a bit here. So right now we're setting a ship always, but we need that to be conditional based on what mode we're in. So if the mode is placement, then yes, we want to place a ship. However, if the mode is attack, we want to place a marker instead. Just a reminder that this is all placeholder and it will be controlled by the actual game logic later. So just so we can test our work as we go, we're hard coding that it's a hit, for example. We're not actually testing to see if it is really a hit. Okay, we can mock up our attack mode here and give it a try. Looks good so far. We have the cursor, the red crosshairs following the mouse. Let's give it a shot. Oops, looks like our shots are occurring way too high. Why is that? Well, let's go back to our code here. If you remember, I mentioned earlier, we want the outside code, so everything that interacts with the map view. We don't want that to have to worry about the fact that these are offset, because it's just going to add complexity to the rest of the system. So everything that's calling this set marker is going to be giving it 0 based coordinates, as if everything was down here. And it's simply going to tell it whether or not it belongs on the radar view or the fleet view. So in the case of our test here, where we're getting a click, we need to actually offset that the other direction to simulate that it's being called by the other part of the system. If you don't understand what I'm saying, don't worry about it, but we need an offset here. So we're just going to subtract the height, basically. Let's try that again. There we go. A hit every time. I'm pretty happy with the map, so I think we can move on to the controller. This component is going to be rather complicated, so I'd like to plan out our approach. We have our outlets for the rest of the UI, that's great. And I think we can go back to the map view and we can remove this test code that we added. Since the map won't be telling itself what to do, the controller will tell it what to do. So we can go ahead and just remove that. Yeah, all of it. Goodbye. So now if we started the game, it wouldn't do anything, but that's fine. We want that right now. So coming back to here, there's going to be a number of things this is responsible for. There's going to be a section for game server interactions. So we'll just label these sections briefly. There's going to be state changes. Well, let's not call it state changes because that could get confusing later. Let's call these game phase changes. And what I mean by that is the game's going to progress from a waiting state while we're waiting for the other player to join to the placement state while players are placing. Then once both players have placed their pieces, it's going to go into the battle phase where turns take place, and then eventually the result phase where the winner is shown. So just like we did for the map view where it has different modes of operation, we're going to define a similar set of modes that this overall game controller can be in. So let's make an enum up here, and nothing else will use this, so we'll keep it private. So we'll call it game mode, since that makes sense. And we'll call it placement, battle, and result. I've left out the waiting phase since players will hang out in the other scene we created, the connecting scene. We haven't built that yet, but this is kind of like the waiting room where you sit and wait while you wait for another player to join you. So game scene will only be concerned with the latter 3 possible states of the game: placement, battle, and the result. So again, just like before, we want to set some functions up. We want to set these up so that we can switch between these modes. Eventually, the game server will be telling the game which mode to switch to, but we'll test them manually to start. We have placement mode, so we'll call this begin ship placement. We have battle mode, and since this could be either for your turn or the other person's turn, we're going to make 2 separate functions. We'll call one wait for opponent, and we'll call one start turn, which is basically the beginning of your turn before you've placed your marker. And I think we might need one more. We're going to need something while you're waiting for the other person to place their ships. So let's just tuck that in right here. For result, we just need one more. Let's also create some private variables. We want to keep track of what mode we're in. So let's create a mode variable. Rather than setting this mode directly, we're going to be changing it in each one of these functions. So let's just go down the list and we'll start with begin ship placement. Now that we generally have our mode switching set up, we can focus on each of these individually. And as before, we'll start with the ship placement mode. And let's build this out a bit more so that we can actually get to a point where we can place a ship on the map, controlled from the controller, not just simply testing within the map view. So a couple of things we want to do. We want to update the message shown to the player So let's just simply change the text of that. Okay, and then we need a way to keep track of how many ships they've placed so we know how many are left to go and we know which cursor to show. So let's create a variable for that as well. Okay, and we'll just reinitialize that to 0 here as well. Now the controller gets to control something. We're going to tell the map view, we're going to tell the map view to enter placement mode. And this was the logic we wrote before, which will put us into the right mode for having the cursor correct and setting the boundaries and all that good stuff. Every time we place a ship, we want the cursor to change to the next ship. So let's make a function down here that's private. And this function will be responsible for updating the cursor to the correct ship based on how many you've already placed. But before we can actually build this function, we need to know whether they are currently placing the ship horizontally or vertically. So back up to the top, and let's add another variable to keep track of that. So at this time, we're going to do it a little bit differently. We're going to create a private variable to keep track of the direction, and we'll just simply keep track of this as, I don't know, place ship horizontally. And we're going to make a public getter and setter, and this way whenever it's changed we can update the cursor, but if we just want the value we'll just return it. And for set, we're going to set it, but we are going to also update the cursor. Oops. There we go. So we'll assign the value being set there, and then we'll update cursor. So like I said, we want to, depending on how many we've placed already, so if we have placed none, we want to have the scout. And this is where our set ship cursor, you'll recall we created that before, back here. Now we get to call it from the controller. And this will be the scout. And for each time we're checking, we're always going to check to see if we are placing it horizontally or not and pass that information along as well. So that's case 0. Now let's just duplicate that a bunch of times, and we'll have one case for each number of ships you've already placed. So if you've placed 1, it's going to be the cruiser next, because that means you've already placed the scout. And if you've already placed 2, that means you placed the cruiser, so now you should be placing the carrier. I think it's time to check our work. So again, we'll just mock the mode that we're in. We'll set ourselves to begin ship placement right here, right when this wakes up, and we should be able to see our progress. So back in the scene editor, we just need to add our component onto the controller, like so, and we need to assign each of these properties so that it can control them. So the map goes in the map view, our message box. We haven't done anything with the button yet, but we'll assign that as well. And there, we should be good to go. Let's give it a shot. Looks good. Well, it looks the same as it did before, but you can see we have the message, place your ships, and we have the correct cursor being set. So if we click, we're still going to get that boat because we haven't told the map view which boat is active. So let's go ahead and go back. Actually, you know what the problem is? We left our test code in here. So let's go into the map view and take that out. Right here. So we don't actually want to do that. We want that information to come from the user's actual ship that they placed. So let's just comment that out for now, and we'll come back to it. I think we need to initially update the cursor here as well, right when we switch, so that it immediately changes to the correct cursor at the beginning. And then we can continue to fill out the rest of our phase change functions here. So let's work on waiting for opponent. I think for this one, all we need is a message, and we need to disable the view. So while you're waiting for your opponent to place their ships because you finished first, we're just going to set the map to disabled. That way you can't place any more ships or cause any problems. And let's set a message to let them know what's going on. That one's pretty easy. Okay, for waiting for the opponent's turn, I think that one's going to be basically the same, but we'll just change the message a little bit. There we go. And when it's our turn to play, let's just go ahead and set a message so we know we should take our turn. And we need to set the map into battle mode or attack mode or whatever we're calling it. Set attack mode. Great. So you can see how separating all of the logic for how these items work into the view class has greatly simplified our code here. We don't have to worry about how any of that works. We just say, hey, map, we don't want them to be able to do anything, or hey, map, we want to do attack stuff and let them take their turn. So it's pretty easy to just call that from here, and now we don't have to worry about it anymore. Okay, so that's all of these. Let's do show result. We can keep this pretty simple as well. We don't know what the result is right now, so I think we'll just put somebody won, or game over maybe. When we actually finish the logic for the game, we'll have that message be conditional based on whether you won or whether the opponent won. You'll notice that between each piece of functionality I'm adding, I'm checking what I already wrote to make sure that it works. Otherwise, if I continue on, I might start adding complexity, and if something doesn't work, I won't know for sure whether it's something I wrote before that's not working, and that's why the new thing isn't working, or if what I'm working on currently isn't working. So let's do our due diligence here and take a break and check each of these super quick. There we go. We get the cursor up here instead of down here and the right message. And then lastly, we want to make sure that, oops, yeah, we already made a mistake, I can already tell. We want to disable the map once the results are shown. So let's set that to disabled, and we'll put show result here. So now no cursor at all. I can click, it doesn't do anything. And we get the game over message. Great, I think it's safe to move forward. Okay, it's time to get a little bit more complicated. I mentioned earlier when we are placing ships that we don't want them to be out of bounds or overlapping. And before we dive into the complexities of that, we need to calculate a couple of other numbers that we're going to use over and over again. So if we just calculate them up front, and we can refer back to them conveniently without having to do that every single time. So the first one we need is the number of cells. And to explain why, I'm going to go back to the Unity editor, and you can see that up until this point we've been referring to every cell in this grid as a coordinate system. So like in geometry, this would be x coordinate 0, y coordinate 0, and this would be 7, 7, and everything in between. And that's really intuitive for a person to think about, especially if you've taken geometry or any early math. But it's not the easiest thing when it comes time to send this over the network or when we need to store this information. So it's actually easier to keep track of all these cells just in a simple list, and I'll show you how to do that. So we're going to make just a simple list or array, and that array is going to contain numbers that indicate what the state of each cell is. So we'll have 0 be empty, and then 1, 2, or 3 indicate what type of ship is placed there. And then for up here, we'll have the same thing, except 0 will be empty, and 1 will be hit, and 2 will be a miss. That way, we just need a simple list, and it'll be very easy to store and check. So going back to our code, let's create those variables. So the first is going to be a count of how many total cells there are in each of the grids. So this is pretty easy to calculate, and we'll do that in the startup routine here. Let's call it cell count, initialized to 0. Okay, and then here, let's take out our test code, and we'll just replace that with a simple calculation. Since it's always a square, it's just going to be map size times itself. There we go. Length times width gives us the total number of cells. Let's do an integer array, and this will be called placement. And that will store where you've placed your ships. Okay, adding on to this, we're just going to quickly loop over all of the possible placements and then assign it to 0 so it's empty. So again, 0 will represent an empty slot. Okay, that's all well and fine. Now when someone clicks, remember back here we commented out this code. mouse down if it's in placement mode. When we were testing just this one component, we were simply putting the cruiser in that spot, and that was fine to test. But what we really want to do is tell the controller that they clicked and let the controller decide what to do. So to do that, this component needs a reference back to the game controller. So let's put that at the top here. And then here, instead of saying that we want to set the ship in the map view component, we're just going to call a method on the game scene controller. But first we have to create that. So let's label a new section here. We'll call this UI events. And we'll make a public function that can be called by the map view whenever a click occurs. The controller is going to look at what ships have been placed and then tell the map to display the right ship in return. It'll make sense once we write it. And right now we're just going to stub this out. I don't want to, this is one of the most complicated functions in the long run here, so we'll just set that there for now, and we'll hook that up on this end. Now we can just say controller, place ship, and give it the coordinate. Back to here. All right, get ready. This one's complicated, and I'm going to be pasting in some pre-written code here just to cut down on the typing, and but I'll explain what each piece does here. So first off, we want to check if we're in the right mode. If the map tells us to place something and we're not in placement mode, let's just ignore it. That's a safety check. Next, we want to figure out how big the ship is that we're placing. So if we go back to the editor and we look, if we have the cursor here, the ship might be hanging off the edge, you know, however long it is. And we don't want that. We want to disallow that. So we know each of the ship's sizes based on which one it is. So let's set up some quick checks. So we'll start with calculating size to 0 and the width and height of the ship to 0. And we'll assume that we're working with the scout to start with. And then we're going to check to see how many ships we've placed so far. And based on that, we'll adjust those figures we just pasted in. So if we haven't placed anything, then we're working with the scout. And that's a 2-cell wide or long ship. And similarly, for 1 and 2, it's going to be the cruiser or carrier with 3 or 5 cells respectively. And if it's something other than that, then it's not expected and we'll just return so we don't do anything else. The width and height of the ship are going to be dependent on whether or not it's placed horizontally or vertically. So let's do a quick check here and we'll assign those accordingly. So if it's horizontal, let me fix these so that they're the right case. If it's placed horizontally, then the width is the size of the ship. And if it's placed horizontally, the height is going to be just 1. That makes sense because it's lying on its side. And the reverse is true if it's the other way around. So continuing on, let's check the boundaries. First, we're going to check the boundaries of the map. And that's pretty straightforward. We just need to see if they're, less than 0. We don't want it outside on the left-hand side. And if the coordinate that they're in plus the width of the ship minus the space that their cursor's in is greater than the width of the map, then we don't want to allow that. And similarly with the height, better to look at this with the map in view. If your cursor's here at 0 and the ship is vertical and it's too long, then it would stick off down to here. So since the numbers increase as we go up, we need to subtract to see if we're in the boundaries or not. So here we're saying ship height -1 and the coordinate is ship height -1. We're checking to see if that's less than 0, and that will tell us whether we are in bounds up and down. And I've omitted checking the top of the map since we're already clamping that, and it'll just, it keeps things more straightforward. Okay, we know if we're in the right mode, we know how big the ship is, what orientation it is, and whether it's in the boundaries of the map. Let's do some quick debugging here. We'll print out a message if where the user clicked is an okay spot to place the current ship. Otherwise, if we don't see that message, then we know something's wrong. Looks good so far. Uh-oh, we have a small problem. Looks like we forgot to assign something. So this is why we check our work. We did not set on the map view the controller. So that's a simple fix. We just need to drag that in there, and we'll try again. Okay, looks good. So if I click here, it says looks good. Here I would expect nothing. which I'm clicking and I don't see any messages, so that's good. That's good. Here, like it looks good. So those spots all look good. Some good test cases would be the corners. All right, happy with that. Let's try hooking up this button next so we can rotate it. So here we can make a new function called rotate ship. It's just going to flip back and forth between horizontal and vertical. So we can just simply say place ship horizontally equals the opposite of whatever it currently is. There we go. And then back in our editor, let's go to that button. And here's the click handler, which is empty. Let's add an object. And we want to add something from the scene, which is going to be our controller is the target. And then on the controller, we're going to set in the controller class, we want to set the rotate ship as the action. There we go. Now that that's being toggled, we should be good to go. Let's try it. Okay, so it's vertical, rotate. Hey, look at that. Now it's horizontal. Do our boundaries still work? Okay, this is good here. We should be able to go all the way to the bottom now. Good there. All the way -1 in the corner. It looks good, but here should not be all right. Perfect. I'm clicking and it's not letting me place it there, so that's good. We could put a little error message or something, but we're going to keep it super simple and it just won't do anything. So now we can visually place the boats in our fleet, but we're not actually keeping track of where they are mathematically. Just because we have a sprite on the screen here, there's no easy way to check where they actually are in coordinate space, or what index they lie at, or whether they overlap each other. So the next thing to do is to record where the user places the ship in the array we created earlier. So here we have placement. We haven't used that yet. We initialized it to be an empty array, and we set all of the individual values to 0, which is empty. So now we need a way to actually check the current state of a cell and also to fill it in, so to speak. You can think of it like when we place a ship here and it occupies these 2 squares, then it's like we're taking a pencil and just coloring those in, and we know that those 2 are occupied by that kind of ship. So let's go back to code, and we'll make a new private function that's responsible for filling in a cell, and we can also use that same function to test if one's already filled in. So let's get started with that, and it'll take a coordinate, the type of ship that we're placing, and just a simple check. If this is true, then all we want to do is check to see if it's open or not. And if it's false, then we actually want to fill it in. So before, when I was describing how we were going to translate x and y coordinates into a single position in our list, it's come time to actually do that now. So we'll call this cell index, and it's not as hard as it sounds. We just simply take the coordinates y position, and that tells us what row it's in, if you will. And since each row has the same number of cells, every row we go up will add that many cells. So that sounds like multiplication, so that will be map size. And then the x coordinate we're in just adds a little extra on. So if we go back to our visual aid here, let's say I went up to, this is row 0, this would be row 1. So if I'm here, I should be in the 8th cell. And then if I move my cursor over, each time I move it over in the x coordinate, I'm just adding 1 onto that. So if we go back to code, we just need to add on the x coordinate to finish out our calculation. There we go. Now we have the offset in our array where this coordinate lies. We need a series of checks to see if the offset is reasonable. So let's make sure it's not less than 0. And we don't want it to be greater than or equal to the number of cells we have, because that wouldn't make sense either, and that would cause an error. So if either of those are true, we're just going to return immediately. We also don't want to allow them to place it where they've already placed another ship. So if the value at that cell is greater than 0, that means there's already a boat there. So we're going to just return if that's the case as well. So our placement list at that position, if that's greater than 0, then we're going to bail out as well with false, which means we didn't succeed. And then lastly, if we're just testing to see if it's okay to place here, then we know we've reached the OK point now, so we'll return true. And if we're not testing, then we want to fill in this cell. So similar to how we checked before, but this time we're going to actually assign the value. And the value we're going to assign is the type of ship we're putting here. This allows us to know kind of what ship you've placed. And then we'll return true. Looks good. So now we can return to our place ship. And I mentioned this is going to be a complicated function, and that's because we need to add some more checks here. We're going to use the function we just wrote to check for overlap. So we're going to use some vector math to make this a bit simpler to write. What we want to do is start from the position where the user clicked, and then sort of count over or down however many spaces the ship is long or wide, depending on if it was placed vertically or horizontally. So to do that, we're going to set up a basic loop again, starting at 0. But we're going to loop the number of times based on the size of the ship. So the Scout, it would be 2, and so forth. And then increment that each time through. And if we're placing the ship horizontally, then we want to act one way. And if we're placing it vertically, we want to do something different. So let's start with this case. So we need to test, using the function we created before, if this cell is open. And how do we know where we are? I mentioned we had to count from where they clicked over the number of spaces. Well, we can do that by just calculating where they clicked and then adding a vector in the direction, so to speak, that we need to move in. So this will be equal to where they clicked, and then we're going to add a new vector which adds on the direction we're counting. And since we're horizontal, we're going to add it to the x component, and the rest of the components will just be 0. So the result will be a new vector that is incremented over by that many places. So now, if we try to set placement in that spot, we'll say check coordinate there, and we know the ship type already from above. And we want to say we're just checking only, don't fill it in if it is open. And I put this not operator here because if it's not passing, we just want to return. Looks good. Now we can copy that down to the vertical case. Instead of incrementing in the x direction, we want to subtract in the y direction. Otherwise, it's the same check. Looks good. Now, if we pass that check, we kind of want to retrace our steps. Now, there is a more succinct way to write this, but I'm writing it this way just for clarity. You could mash this all together into one thing, but it would be a little bit harder to understand what's going on, so I'm separating them out into 2 separate loops. So we know that from this point down, we're good. We know we can place the boat where the user clicked. So now we're going to call the same thing as above, but we're going to actually fill it in. So for that, I'm going to just paste this in. Okay, now we've filled it in our internal list, so we know what spaces it occupies, but we need to update the view. So let's tell the map view to set a ship of the correct type at that spot. There we go. We've done all the necessary checks, and we know it's safe to tell the view to update accordingly. And we also need to update the number of ships we've placed, so we'll just increment that with ++. And let's go ahead and update the cursor as well, because now we should be on the next boat, or no boat at all if we're finished. So speaking of which, let's do a check down here. We know if the number of ships placed is 3, we've got them all. So we can simply tell ourself, basically, to wait for the opponent to place their ships. Okay, so now if we run this, I expect that we should be able to go from one ship to the next, placing them on the map with boundary checks, and we should see them show up. Okay, starting with the Scout. Well, we already have a problem. Let's check it out. Oops, we have a typo here. So let's quickly change that to be cell index. There we go. Okay, back to the Scout. Place. Look at that, there it is. Let's try rotating this one. We'll put it right next to it to confuse our opponent. Looking good. Now this one I should not be able to place here, 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 here. And if I rotate it, none of those spots should be valid, but I can place it here in the corner. Hey, look at that. I think we're almost done with the UI. We need to do one more thing before we switch over to the server, and that is to remove some of our test code from the map view and hook that up for real. So in here, remember we commented this out to set the marker. We don't actually want to do that. We want to tell the controller, like we did here, just that they clicked there, and then again let the controller decide what to do with that click. So let's go stub in that function. This will be a public function since it needs to be called from the map view. And we'll call this take turn, because when you click in the radar view, you're essentially, that's what you're doing, you're taking your turn. So we'll call this public void take turn, and it will take the coordinate that they are clicking in. Okay, and in here we will calculate the index again. So this is the target index, this is where you're attacking. Again, it's the y coordinate times the map size plus the x coordinate. Anything grid-based you ever do in games, you're going to run into this over and over again. All right, now here I'm just going to leave us a message to send this to the server. It will be up to the server to check where the opponent's boats are and to register the result. You'll notice we did not create an array here to keep track of the opponent's boats. We don't know where the opponent's boats are, and we shouldn't. This goes back to the beginning when I said it shouldn't be easy to cheat. There's no way from this copy of the game running to know where your opponent's boats are. Only the server knows that information. So we're keeping track of where our boats are, so we can show them on the map and we can tell the server where we put them. But to find out whether or not we have a hit or a miss, we'll have to send that to the server. So for now, let's just go back down here where we made this, and we'll leave it like this for now. A little message here so we don't forget where that goes when we do the integration. I think I'm going to call it there for part 1. That's pretty much all the UI sorted out. In part 2, we're going to look at the server side and how we're going to set that up using Colyseus and Node.js. And that won't take us much time, actually. It will take us less time to set up the server than it does to create all this UI. And then at the end of that episode, we'll hook it all together so we can actually play the game. So I'll see you in part 2.